Welcome to Blue Glasses Math. In this podcast, we will explore how our self-perception as math teachers and learners influences our approach to life. Whether you identify as a math enthusiast or not, this podcast is for you. Are you a teacher, a parent, a school administrator, or a student? Join me as we shift our perspective on what it means to be a math person. Let's take a look. To keep it safe.
Okay.
All right.
Sounds
so
good.
We are here. So, Jill, let's try again. You are here.
One question. I've just put on a shirt, so continuity issues. Is that a problem?
No, you look amazing. You look amazing, James.
I just suddenly put on a shirt.
Do we need to do the intro of like, oh, I'm here with Jill and James? Do we need to do all that again or no?
Well, okay, so I'm here with Jill and James, and they're here to talk today with us about SmartWithIt and their new venture. And we're going to be really authentic here. We've had a lot of recording issues this morning, so we are recording now on Zoom. We are back, and we were in the middle of Jill telling her story about how you landed here.
How I landed here.
With your math story. Yes. So let's do it.
My math story involves being pretty good at basic algebra in 7th grade and getting bumped into the 9th grade class. I was at a small school, and I found I was a little lost at first in 9th grade algebra, having been sort of plumped in there middle of the year because they thought I was just bored out of my mind in the 7th grade pre-algebra class. But anyway, when I look back at that, I actually think it was just, I had very low content knowledge across all of middle, high school, college. Like my parents, neither one of them had working knowledge of science. We didn't talk about world affairs at home at the dinner table, but I had great, what you might call a fluid intelligence, where I could recognize patterns. I could memorize things if I needed to for a test in the short term. I had good abstract reasoning skills. And so even though I was excelling in math, there were other signs early on that I wasn't actually thriving in all subject areas. And when I went to college, I graduated valedictorian in my class of whopping 14 kids, but I did not have in me a lot of content knowledge, as I mentioned, and I also just didn't have a reliable way of gaining that content knowledge. And so math actually became a bit of a safety major for me because it was a space where I was actually allowed to not know a lot of content knowledge, not allowed to not know the human story of mathematics or how we ever discovered that there was a pi to begin with, this magical value of pi. None of that was part of my education. I could memorize 30 pages of calculus proofs, but actually even asking me to explain the big point of calculus, I'm not even sure I would have done it at the time. Mm-hmm. And I think I chose the wrong major for myself ultimately as a result. I think I would have been much happier studying economics or I don't know, something else that was a little bit more human-centric, because that's where my interests are. And I think that I came to SmartWithIt knowing both that so many students rule out whole career paths because they don't have a good experience of math, which I think is just an injustice to them. That they don't see themselves as smart potentially because they don't have a good experience in math. They don't see themselves as capable. Like, it expands beyond, not only do they say, I won't major in anything that requires a math course, might not go to college at all, they also just don't see themselves as being as competent and prepared to have a grand career in something that is academic in any way, shape, or form. And so that bothers me. But also, I think that we are doing an injustice to all of us to not tell human stories about math and science and how we got here to this place in this world today. And so it is that desire for content knowledge. One of the things I was reflecting on when I looked at your question, Pam, is like, you asked this question about like, what were the moments of emotion? And it used to irritate me terribly. I was majoring in math and I would tell people I was a math major and they'd say, oh, what are you going to do? Teach? And it just drove me batty that they would say that, because I'm like, surely it's good for something else. I don't know what that thing is, but surely it must be. And so even though I loved teaching, I was the person tutoring my friends on the phone and just enjoying every minute of it, but I did not go into education because it irritated me that I thought there was something more substantive to be doing with the math. And so I ended up getting a job as risk assessment analyst. I was calculating the probability of things going wrong at a nuclear weapons facility because I lived in the Panhandle of Texas.
That's amazing.
And from there, I ended up doing that same thing at the Johnson Space Center in Houston. We were at the nuclear weapons facility. We didn't approve anything unless we could show that it was less than a one in a million chance of disaster. At the space shuttle program, we put people up on that shuttle knowing that it was like a 1 in 350 chance of disaster, which was really interesting and shocking. At any rate, so I am here because I've become such a student of how it is that we can reliably get new content knowledge and how it is that we can leverage the human stories of our content knowledge in teaching math and science and change our experience of that as a whole.
Amazing. Amazing. Wow. So yeah, so all of the emotional experiences that led you to this moment, like kind of helped to inform what you're doing at SmartWithIt. Awesome. So James.
Oh, golly gee. Well, first of all, I'm so honored to be working with Jill, and I think our stories are very similar in very dissimilar ways. So really, well, schooling was very formative for me in a negative way as well. So I grew up in Australia, did all my K-12 work there and my undergraduate work there. And it was very Anglophilic at the time. It really was. Classrooms were sit and desk, face forward, and never question the teacher. And I did have two formative moments I can remember where I did actually question the teacher. One was in grade 5. We were learning long division, doing a worksheet of, I know, some awful number of problems to do, just long division. And I was good at it. I could do it. I was very, very capable of memorizing that procedure. But I did ask my teacher, why does it work? And the response was, go back and finish your worksheet. So I kind of knew then that my job as a student was not actually to understand the mathematics, but to please my teacher. And I got all my gold stars, all those worksheets. I was a very good student. And then in grade 9, I had the audacity to do the same thing again. We were learning the Pythagorean theorem. So I'm in a big public school in Australia. It was actually 37 kids in the classroom.
Wow. And
we were told this day to get out our rulers and compasses and protractors and so forth and draw 3 examples of right triangles, measure the side lengths. You had to call them A, B, and C because you always have to call the sides of a triangle A, B, C, apparently. Work out A squared, work out B squared, work out C squared, and see if A squared plus B squared equals C squared. Do it 3 times. Okay, that was the mode of instruction. I did it, and I had 2 problems with this. And the first one was, I don't believe anyone could actually draw a perfect right triangle and measure exactly to actually see A squared plus B squared equaling C squared. Always going to be human error.
Always.
I put that aside. That was fine. I'll let that one slip. But I did go up to my teacher and I said, excuse me, sir, how do we know this didn't just work as a coincidence 111 times in a row? I thought, okay, we had 3 times 37, I think it's 111. Yeah, 111. We had 111 examples. How do we know it's just not coincidence? And his response to me was, go back and draw another 3 triangles. Wow. So I just learned I am not to know why the Pythagorean theorem works. That is my job. I'm going to have to do it on my own. And I spent years wondering about it, and I did some reading and so forth and figured it out in the end eventually. But my schooling was not for me. It was just to please some emotionless, contextless, non-human experience. I did not like maths one whit. Even though I was labeled gifted at it, I thought that was actually kind of silly. I was confident that I was just working to please my teachers. And then I fell into math at university. And I took an abstract algebra class. And abstract algebra is really about, essentially, why does arithmetic work the way it does? Yeah. It's the why questions. Is it what I've been longing for 13 years in my schooling? Why do things work the way they do? And I absolutely loved it. Most of my colleagues at university found abstract algebra just way too abstract and hard, but it just resonated with me. And I just knew, oh, this is what math is really about. Yeah. And I have been a mathematician all along. And then I went all the way through with it. Changed my degree to get a math major. And that's what led me actually to the United States in 1988. I actually got into the Princeton program and got a PhD in mathematics at Princeton of all places. But that worry that I had to wait 14 years to see what math could actually be really actually made me angry. So after I got my PhD in mathematics at Princeton, I didn't go into the research world. I said, well, first of all, I didn't know what to do. I did the expected thing. Got a PhD in something, go become a professor. So I went to college and became a professor. But I chose liberal arts college environment because I wanted a strong focus on teaching. Mm-hmm. But then this feeling really stayed with me that I had to wait 14 years to see what math was. So then I started looking at the curriculum, this was around the year 2000 or so in the US. And I have to say back then, what I saw was the same dry, memorize, don't ask questions, just do curriculum I had experienced decades before on the other side of the world.
Yes.
What is going on? What is going on? So I decided if I really care about this and I'm honest about this, I really need to understand the K-12 system. So I decided to become a high school teacher, and I did. And what was lovely about this is some lovely irony here. I'm not actually qualified to teach. I don't have a single education course under my belt, so I can't actually work in the public school system. But private schools can hire whoever they want. So I worked in the private school. So, I did the whole thing about being a full-time teacher and a dorm parent. But I don't do sports. I can't coach sports. That's just not James Tanton at all. So I made a deal with the heads. Like, how about I start a math institute for you where I do like a math circle program for students in the Boston area and do some training for teachers. And I hooked up with Northeastern University and I helped them create a Master's of Education program in mathematics. And I designed the 5 core math courses for them and taught them. And I love the irony that I could teach teachers how to think about and teach math without actually being qualified to teach myself in the government's eyes. So that was just perfect. That was just perfect. But my point was that math is an intensely human experience. I mean, it's been around for tens of thousands of years, not because people like to memorize formulas and pass exams. There's something innately compelling about it. It could be the compulsion could be from the practical side of it all, or just from its innate beauty and its intrigue and wonder. Whatever delights you, go for it. Math can offer it for you. It's a beautiful, vast human subject. So I've been working very hard to try to bring the human story back to mathematics. Why did humans care about this in the first place? Why might we still care about it today? If you've got a practical approach, fabulous. But, math's also got this beautiful artistic, creative approach of just that wonder. And I even use the word awe. I believe mathematics is awe-inspiring. And I would just love kids to see that. And as Jill says, I don't want everyone to necessarily fall in love with math and become a math major, but at least know there's something they could fall in love with if they ever chose. I'd also say that the other thing about the saddens me about the K-12 curriculum, we do teach the wonderful works of Shakespeare and other great human accomplishments because you should know what some great achievements of humankind has been. Just be aware of at least one play of Shakespeare, something like that. And mathematics is a great human accomplishment, and we don't talk about why it is one and celebrate it at all. We never talk about what's the intellectual delight of this. And sure, I might say, yes, we need to give a sense of calculus, not because there's always a race to calculus, but be aware that calculus is one of these huge breakthroughs of intellectual achievement, that just be aware of what calculus is about. Not do it, just be aware what it's about. And even things like the number pi, even things like the story of place value, the fact that we humans love the number 10 so much because of the digits on our hands. Have you ever noticed that we
I never even thought that. I never made that connection of their digits.
No, I know.
So
literally,
said that. My head is exploding.
We don't talk about these fabulous things because math is intensely human. Mm-hmm. Let it be human and let it shine for that. So I guess it's like a source of like a frustration, anger compel me to as well. Please can we make a kind, human, connected, and real experience of mathematics to offer our fabulous kiddos K through 12, as well as the abstract algebra class at university that made me fall in love with math.
Amazing. I love it. That was like your manifesto, James.
It is, I
know. For sure. And that's why I've been wanting to bring, as soon as I met James and started interacting with his way of talking about and thinking about math and math instruction, I started to eat up. I was purchasing all of the books that he had available in his self-publishing website. And I had just been really longing to bring them to a more prominent place in our society so that this is the common experience of mathematics as opposed to what the rest of us had for all of these many decades.
Yeah, it's beautiful. I was actually with parents last night at a local public school, and we were talking about teaching and learning math and how it's different. And there's always fear in changing things, right? Because people are like, okay, well, this is how I learned it. But what really made an impact was when I said to the parents, there were parents of kindergartners in the room, a lot of kindergarten parents, first grade, second grade. The oldest child people had was like fifth grade. And I said, so kindergarten parents, how many years will it be until your child steps out into the world to get a job, right? And they were doing the mental math, right? And I said, and 2 years ago-ish, we were introduced to ChatGPT. And then I just didn't say a word. And they were like, oh. So we need to do it differently. We need to teach kids to think, right? And the way we learned math did not teach us how to think or reason or sometimes I think the anxiety and the negative emotions that people maybe have experienced in math class are linked to the fact that we were not allowed to be human in math class, right? Like James, when you were saying your teacher was like, go back and make 3 more triangles, just do it. be a computer, right?
Exactly.
And yeah, and so that's why it's because we haven't been permitted to be human in math class, and up until I think we're making strides now, but it's principles and standards for NCTM have been out since 1989, and we are recording this in 2025. Like, it's time to go.
But you're right, change is very hard. It's very innate for us humans to not want to change, and I get that.
Yeah.
And one thing I think is also problematic is that it's often very easy to equate familiarity with understanding. I was so familiar with that long division algorithm. Now I was obviously a strange child thinking I don't need to know why, but most people, when you do like 500 of these things, you kind of feel like you know it and understand it. But if you're asked to explain it, you suddenly realize you can't. So what are we doing? Especially something like the example of the long division algorithm of the 21st century. If I really want to work out 276 divided by 12, sorry, I'm going to ask Siri because she'll do it better than me, and faster than me. So it's not about getting answers anymore. Then the only thing it can be about is the thinking behind it. And I'll gladly teach the long division algorithm. Don't get me wrong. I think it's actually a beautiful way to have a discussion about the brilliance of our place value system. One of humankind's greatest achievements, how we write numbers today, is actually a great achievement. And something like exploring long division can really highlight how profoundly beautiful it actually is. And think about the structure of numbers, not just get the answer 276 divided by 12 is 23. Totally. Okay, great. That's exciting. Check. Move on.
Yeah, totally. Yeah. I love what you just said about familiarity. Go ahead, Jill.
I was just going to say, I love the point that James made about if I wanted to, I could do this someday. Because we use this term like math people. It was one of the questions you gave us to think about ahead of time. But in other spectrums, we don't say like I'm a music person or I'm not a music person.
Yeah.
We have terms like musician or maybe I'm an avid reader. But those things are not like sort of predetermined yes or no's. Like if you're playing violin in orchestra, do you call yourself a musician yet? You might not. It depends like how much you do it, how much passion you bring to doing it. Are you really making it an integral part of your life or not? And I don't want to say like, are we math people or non-math people as though it is this fixed thing. I think it's more about like just having it be just like any other aspect of humanity that we might be really into for a period of our lives, or that we might be relying on in some way, shape, or form as a profession. But if we're not, that doesn't make us sort of like permanently not the musician or not the artist or not the avid reader or what have you, right? I'm a perfectly competent reader and I've learned to love reading, but I also wouldn't call myself an avid reader because I just prioritize other things in life right now, And so I like it being more of an open door type characteristic of just some part of life that we may or may not be exploring thoroughly at the time.
I agree. 100%. So we recently met one another in person at the NCTM conference down in Atlanta, Georgia. And
that was so fun.
It was so fun. And what I noticed when I came to your exhibit at SmartWithIt, I noticed that people were doing math. And I was also at a booth where people were doing math, right? So you're going to these conferences, and the idea of the exhibit is for people to kind of like display their wares, if you will, right? Like, what are the things that you can bring into a math class? But I think what was really unique about what was happening in both of our exhibits was that we actually had people like sitting with dry erase boards, sitting there doing math and having conversations about math. And I thought that was beautiful. So let's start talking about SmartWithIt. So SmartWithIt is a new program. I'm not going to butcher it, but like I'll give you guys a chance to like tell me about SmartWithIt and what is it all about?
Yeah, I would say SmartWithIt is really about bringing human-centric approach to learning to the masses, if you will. I want to like apply cognitive science so that our learning products work like we work and, release the dopamine and things like that we want to be released so that we can learn reliably. I think, and so my passion is not just bringing it to, in particular, schools necessarily. It's just bringing it to humanity also, right? So I think schools is a big place where that's already happening. Certainly want to bring it in and change what's happening in classrooms today. Also want to make it more widely available for people to just, like, as I found myself hungry for content knowledge, it was actually really hard to find. It was hard to find those stories and get that access to things. And so I want to make that human-centric approach to learning just more widely available, period. And the first way that we're doing that is by introducing this all the maths 612 math curriculum for use in schools.
So when
And
you
it
said,
really is all the maths. Of course, I've got British sensibilities, so
Yes.
maths rings well to my ear. But speaking to math is many varied smorgasbord of beautiful topics, aspects, flavors, delights. So when you say you're not a math person, you're talking about which part of math doesn't tickle your fancy, because there's so much more than just any one item. And I think talking about all the maths is really important. Some people are very, visual, and they love like arranging dots on a page and actually come up with incredibly like potent formulas, summation formulas, just by thinking visually about dots on a page. Absolutely fabulous. Some people are much more analytic and really love like grinding through algebraic equations. They see that structure written that way. Absolutely fabulous. Some people like turning their laundry inside out and realizing that a shirt inside out still looks like a shirt, and a sock inside out still looks like a sock. There's something there about topology that actually, why does turning things inside out preserve shape? Does it always preserve shape? That's a brilliant math question. Would you ever see that in the curriculum?
no,
But
I never thought of that.
yeah, people who sew like blow my mind. How do you sew a lining onto a dress and have the hems do all the things they're meant to do in those weird topological ways? Mind blowing. What a math person that is, So exactly. So it really is all the maths. And yes, we've honed in on Algebra 1 to start off with, which is the typical first high school experience for kiddos, though it's often being pushed into middle school now. And to me, that's the one where something fundamentally changes the nature of the curriculum. And this is where, when I left the university world to become a teacher, I thought deeply, do I want to go to elementary school, middle school, or high school? And I ended up choosing high school because I actually thought, I'm going to sound a little rude here, I thought it was the most joyless arena of all three math arenas. Because the culture at the time seemed to be, in my perspective, was, okay, kiddos, all fun and games are over. We're now in lockdown mode. Our job is to get you through those exams and get you into university. Okay, that's the nature of it. And one of the culture shocks I had when I became a high school teacher is how much pictures are avoided. Like, don't draw pictures. You only draw pictures in geometry class, and you draw pictures of graphs. So did I ever see a picture of completing the square in a quadratics course? Like actually draw a picture of a square with a bit missing and find what the bit has to be? It actually makes beautiful sense because it really is geometry. We talk about the squares, x squared, x to the second power, we use the geometry word. X cubed, x to the third power, we use a geometry word. A natural question to ask kids is, why don't we have a geometry word for x to the fourth? What's going on? There's something human there about our human limitations. I have no idea what the fourth dimension looks like. It's just, that's the thing, that we just strip all that, I don't know, quirky joy and actual joy from our first high school experience, because we're now in everything's analytical, everything's grind, everything's to get through, I don't know, a checklist of things to get through. And you pass an exam, and voila, now you're set for university or whatever you do in life.
And now you're worthy, right? Because you did all that.
Yeah.
But this is much more human. On your website, I'm reading, it says, finally, a math program with some passion and heart. And I love it.
Yeah.
Can you give me an example? Like what would it look like? Like maybe.
Well, it's interesting that quote came from our very first presentation on all the maths. We were presenting to a review panel for the state of California. At the time, we were hoping to get our course done in time to submit to their state review. We ended up withdrawing and saying it wasn't going to be ready, but we did present to this panelist to sort of give them all of the details of how to review the course. And we were we sat in on several other content providers there doing their demos, and they were quite dry. But we were the only, I was like, is it okay for me to ask them to do some math at the beginning of this presentation? Like, is it okay for me to talk to them? Because there was a very formal thing, and they were like, yeah, you can do that. You can do that. So we just jumped into lesson 1 of our algebra course and started to show them what we were all about, right? And I think it was just that the panelists reacted to the experience of being engaged and delighted. And they were the ones who said, finally, we are, of all the things we've been looking at today, finally we see something with some passion and heart. So that
I just got the chills. It's got the chills.
We treasure that.
Yes.
Yeah. And so, but I think in terms of like what I think of when I think of how do I bring passion and heart to this work, I think it's like recognizing the state that we are in and knowing the amazing good we can do for each other by doing it differently and by bringing that sense of humanity and also the skills. Like we also have an element of our program which takes advantage of the cognitive research of spaced recall. So
Mm-hmm.
when I personally, again, I struggle to take on new content knowledge unless I'm giving those very human conditions of like a bit of dopamine because I'm being in some human interaction and I'm having this lovely human experience of like an aha or perplexity. I'm engaged by my desire to predict or do something, solve a puzzle or what have you. And so you need that. You also need to be able to convince your brain that you actually need to retain that information beyond this present moment. And that happens very reliably if you ask your brain to remember it at a certain sort of algorithm, if you will, of spaced repetition. So you need to ask your brain to remember something the same day and maybe the next day. And then you need wait a little while till you're almost forgetting it, maybe 2 days later before you ask it again. And then 4 days later and ask it again. And so part of what we're bringing into this core curriculum is that spaced recall where students go home after school and we are prompting them with text messages to just watch a little GIF of us doing a little bit of math here, little video, short thing. What is that thought that you need to know? What do you need to think about what to put here? And they can answer very quickly, concisely. Yeah. It doesn't require them to get out a piece of paper and do a long procedure.
Yeah.
It's not actually a math problem. It's just
like, oh, that's the key idea. Oh, yes, that. And responding. And it really doesn't even matter so much if you're getting it right or wrong. What matters is that you're asking your brain to remember what that experience was about.
So it's not like doing more problems. It's more like just remembering something about what you did earlier. Interesting.
About what you did earlier. And so it's, what we're doing here with the Passion and Heart is just taking advantage of what we already know from cognitive science about the way our brains work, that if we have human teachers telling human stories and we have reliable spaced recall, learning becomes the default. And if you think about it, like, not to hate on anything, but like Khan Academy is the opposite of all three of those. You do not have human teachers engaging your brain. You do not have human stories being told. You have the same procedural thing being put out there, and there's nothing to keep you with spaced recall. The spaced recall really hit home to me one time. I was working with a 9th grade student who had never mastered fractions and always felt like this sense of like, oh, I cannot do math because I cannot get this. And I was actually using James's fraction unit to work with the student. And I mean, they were having so much success. I was working with them virtually. The end of this, like we kind of like had several lessons in a row, and then we got to this point, and they did this champion pose on the Zoom. I mean, they were feeling on top of the world because finally they got it. And then what happened is they went on vacation a week or two, and maybe somebody got sick. 2-3 weeks pass, no recall. Given the question again,
gone.
Don't have it. Gone.
Heartbreaking.
And that is the problem with it's the problem with there being gaps is that the teacher can do an amazing job of even filling in the gap in that moment.
Yes.
But if no one's following, how can they, make sure to follow up at the right spaced recall for all of the students for all of the gaps, right? So I do think there is a real place for that that spaced recall, and I think I'm excited about getting this out there and getting it in use by students so that we can see how they're responding. I really think it's going to make a big difference. Not only is it not about getting on a piece of paper and doing a lot more problems, it's even because we're doing it via message, you don't even have to say, oh, I'm going to do this for 15 minutes right now. I'm going to open my thing and do the thing for 15 minutes. You can answer a question once at 3:30, answer another two more at 5:30. And, at the end of the day, maybe you got 2 more left and then you're done. And it's literally 5 minutes of just prompting that brain to recall what you did that day and what you did 5 days before and what you did 20 days before. So that
the actual experience is just literally just responding to a text, just quick
text.
Response. That's all it is.
That's amazing. And there's nothing like that out there. I don't
think so either.
Nope.
Amazing. What else did I want to ask you? Okay, so can we go back to the panel for a second, the California panel that you said? Yes. Because I can picture some people listening to this and be like, okay, sure, you gave them some math problems to do, but I'm sure it wasn't like just a typical math problem that people, it might be typical to us in this space, right? But like, What was it about that task that where
Mm-hmm.
they were thinking, oh, finally a math program with passion and heart? Or the
I think
conditions
that,
of how you gave that task, maybe.
yeah, the task, first of all, it leaned on human intuition
Mm.
instead of putting forth some contrived context. So I cannot believe how even the highest ranked programs today still put out there a context like let's plan a pizza party, implying that this is why humans created algebra. When it is so not.
We
When
did
it
not
is so
create
not.
algebra so we could eat pepperoni pizza.
Yeah, exactly.
No.
Yeah.
That's funny.
So we were just asking them to predict the next number in the list and demonstrating how we are not going to put forward those contrived contexts, but actually lean into the human propensities that gave birth to mathematics and gave rise to mathematics to begin with. I think also, the California framework was asking that the curricula be focused on big ideas. And they said to the publishers, you don't have to use these big ideas, come up with your own. But all of the publishers were, I think, nervous to do that. And so that whatever example big ideas there were, they went with those. And I think this was the first product that said, no, there are some really big ideas. Let me tell you about them.
Amazing.
And one big idea is that, yes, math was born from our human instinct to compare and predict and build things and explain things and whatnot. But then we're also playful human beings, and math went beyond our ability to compare and predict, tally things up and whatnot. It went beyond that, and we started like just playing with math. And then science kept finding these uses for all of the things they were doing that were playful.
Yes.
Right?
Yes. Yes.
And so that story that math is, as James likes to say, bigger and bolder than any one real world application, comes to the forefront. And that is a big idea that we actually come to we come and revisit that idea at the end of each unit. We're revisiting one of two overarching storylines. That's one of the two. So I think that was another reason why they responded with that whole sense of and at the end of that lesson where we asked them to predict, that unit is called Trusting and Not Trusting Patterns. And what I love about that unit, and again, all credit to James for writing this trajectory, we sort of challenge our trust in patterns in the first lesson. Then we kind of lean back in and be like, hey, we can actually build our own formulas for any pattern we want. If we believe in patterns, we can do this. Then we come back and we start challenging it again, in this context that everybody is so sure that we can believe in this pattern because it's geometric, it's physical, it's in front of us. And so we did that same thing in the lesson. We kind of skipped through and sort of previewed the end of that unit. And I think that also really, really got them engaged and delighted with how just when you think, okay, I can trust patterns again, then you're like, what? You mean I can't trust the pattern?
So the big message here, this is why I actually
Yes.
really love this unit as well, even though tooting my own horn, it sounds like. It's really teaching a sense of agency and helping the experiencer of this thing ask, how do I know what I think I know? Because we teach in that lesson that, yes, you can lean into a pattern and make a good, solid, educated guess for what's coming next, and you can actually have justification for great, fabulous, grand. But now we also give the audience right there the power to make the next number be whatever they want and find a way to justify it with mathematics. That could be, if you've got 2, 4, 6, 8, and you want the next number to be 57.5, do you know what? You now have the power to actually make that happen, and you can write a mathematical formula to justify it. So now you've got the power to make patterns go awry. Yes. But then with that comes responsibility, because we do like to lean into patterns, as Jill was saying. So the question is, now that you know patterns can go awry, if you want to use a pattern, feel free, but it's now your responsibility to justify why that pattern might be appropriate in whatever context you're doing with next. So this content is really about teaching student empowerment and agency. And everyone talks about this sort of thing, but we mean it.
Yes.
That you know you can make things go awry, therefore you have responsibility now, and you can make choices and what to do with that responsibility. That's really powerful. And just one silly point, but I'm also, it's just one of these bugbears of mine. We say kindness is our curriculum. Look at a math book. Every textbook question is, solve this, do this, find that. How about please solve this kindly? Just can we teach the reader some respect, be kind, not do these 50 problems. Do questions like, Do as many of these until you feel like you get it, and then maybe just do a couple more at the end to make sure you're convinced you've got it. So if it's just 3 problems, great, do 3. If you want to do all 50, do 50. Give students a sense of agency of their own learning as well. That's what I mean by an empowered citizen for the 21st century. That's what mathematics can teach so beautifully. And I think mathematics is a beautifully, actually emotionally safe place to teach a sense of agency and questioning, how do I know what I think I know? Let's do it. That's what a great gift to the world, if we have citizens who can really question their own understanding, own learning, and own approaches to learning.
Amazing. As my puppy agreed with that because she just made like a little sound. She's like, yeah, bring it. Bring the agency to these kids, right?
Yeah, puppy and me, we're on it.
Because that's what we need, right? That's what the world needs right now. And I think this is a great place to sort of bring it home and wrap it up. But I just, I thank you so much for the work that you're doing, because I really believe that we need more people that are focusing on the human aspect of teaching and learning math. And I'm not just talking about, like you were saying earlier, Jill, like, let's talk about making a party or pepperoni pizzas or whatever.
Right.
It's like sometimes we convolute these contexts, and like there's I think it's is it a Peanuts cartoon, and it's like a picture of like maybe like Linus or Sally or whatever the characters, maybe Charlie Brown, and it says like, why would anybody ever need to buy 343 cantaloupes or something like that?
Exactly.
Like that's what the kid is thinking. Like,
Exactly,
okay,
yeah.
I'll do the math, but I don't know why. Or like, how would you think?
So you tell me you know the area of the rectangle and its perimeter, but you never actually measured the side lengths. Who are you?
Exactly. So just giving opportunities for more, like, when I say, like, I don't know, it's a contextless context is what it sounds like.
Yeah.
But I don't know if I'm saying the right thing, but like, you're not. Yeah. Go ahead, Jill.
It's not. It is, the context is real world, but the problem is not real world, right?
Yes.
No one. If you wanted to, I remember Yeet Benhard was one of my trainers that got me in love with curriculum and pedagogy, and he used to say, here's this problem about so-and-so's allowance. If I want to know what his allowance is, I'm just going to go ask him.
Exactly.
Right? So yes, the context might be real world, but the application is not. And I think, students entertain that quite a bit in K-5, and that's appropriate and delightful. But by the time they're in 9th grade, they're actually really serious about their lives, and they're not going to. They need a reason. They need good reasons to understand what they're
and
saying.
don't get me wrong, it could also just be a puzzle. Here's a quirky puzzle, which is the case. I say, make it absurd. We're going to have 3,047 watermelons and 29,000 clementines. Just be absurd. Own it. That's fine. Everyone loves puzzles too.
Yeah.
Yep. Yeah. Amazing. Well, so let's wrap up I could talk to both of you all day. It's a rainy day here, and my power is starting to like brown. So I'm like, okay, this would be a perfect place.
Oh gosh.
I didn't want to cut you out. So I'm going to put this in the show notes. I'll put the website, and I think that you said that you're available on LinkedIn if people wanted to connect with you on LinkedIn, and I'll put all that in the show notes. Is there anything else that you wanted to share before, like if you could give advice to, actually, let me back up. The question that I love, and I think this is an easy one for both of you. What gives you hope in the math education space? I asked my husband this. I said to my husband one day, we were driving. I'll just give you the context of where this question comes from. So this question comes from Brene Brown, who's a huge fan of Brene Brown, and she talks about hope. And I said to my husband one time, he's not a mathematician, and I said, I said, I think doing math can give you hope. And this is my very stoic husband. He's very like flat affect, and he started to cry. And I looked over, he was driving the car, and he said, that is powerful. He's like, it gives you hope because it gives you an opportunity to like change your mind and like you said, like break it and fix it. And so anyway, so that's my question. That's why I asked this question. What gives you hope in the math education space right now?
Neat. For me, I think the hope, it comes from, I feel like there is finally a bit of energy and attention and love being paid attention to high school math. And it's been a long time coming. I know, in 2010, there were new standards across the nation, and there was a lot of attention in K-5, and that even spurred up to K-8. but high school has been sort of neglected for a very long time. And I think the assumption was if we fix it at K-8, it will fix itself. And I'm really glad to see states. I don't have raw data, but I have this feeling from conversations that actually people are starting to care and pay attention to what's happening in high school math. So that gives me a lot of hope.
Amazing.
Wow, that's beautiful, and I agree. I guess the other piece of hope has been my own personal relationship with mathematics, that somehow mathematics is big and bold and transcends our humanness in some sense. It's been around for thousands of years. It will stay around. I mean, I guess I'm very platonic in my views. I believe it's just there and waiting to be discovered for all of humanity whenever humanity is ready for it. And I think Jill is right. I think our K through 12 human audience, especially the high school audience, is actually ready to see mathematics, own mathematics, experience mathematics, and be empowered by mathematics.
Amazing. Well, thank you so much for sticking around today and for sticking around through all of our tech issues. I appreciate that.
Yeah.
And
thank you, Pam.
Yeah, of course.
Real pleasure.
I
Absolute
love it.
delight.
So fun. All right. Well,
Really
have a great day. Thank you.
Thank you. Bye. Oh.
I'm Pam Brett. Thank you so much for joining me on this episode of Blue Glasses Math. Please follow me wherever you get your podcasts and follow along on the conversation on Instagram. And remember, being a math person is all just a matter of perspective.